So let's move on and take a look at how this device works. So let's take a look at the boot up process. Now, I put the boot up process of a PC right next to that of a router. And this is really important. And many of us may not know the boot up process of a PC, at least not the details of it, or we may have never written it down. However, the boot up process of the PC is very precise. And since a router is essentially a PC, we're going to find out that the boot up process is very similar. Why do we need to know this boot up process? Well, for several reasons. One, there are features on the router that we need to take advantage of, especially when we need to do something like a password recovery or restoring a broken operating system image, where we need to know how to repair those things. On a router, you have to know that process in order to accomplish the repair. On a PC, PCs are a little bit different. There's a lot more documentation out there. We oftentimes do not have to know the order that our PC boots up in order to determine the problem. So, let's take a look. So, on both the PC and the router, the very first process is post. What the heck is post? Well, post is the power on self-test. So it is a little test that runs to make sure all the components work. If one of the components fails post, the device won't boot. So it's a pretty, if post doesn't pass, the device doesn't boot, something's seriously wrong. You should get it fixed. After post runs on a PC, the next thing it loads is the basic input output system, BIOS. Right? The BIOS is the basic set of instructions to get the system running. So the idea is this: we have a bunch of hardware in our system, and in order to use the hardware, we need an operating system. But in order to get the operating system loaded on the hardware, we kind of need an operating system to tell us where the hardware is. But in order to put the operating system on the hardware, we need an operating system to do that. So you end up in this catch-22 of needing an operating system to get the operating system installed, but you can't get the operating system installed because there's no operating system. BIOS is this kind of kickstart to that whole system. It loads a very minimal set of instructions into memory that can then be used to call the operating system on the PC. So once BIOS loads, it finds the operating system, and it does that through looking through all the drives on the PC. And you, as the user, get to specify the order that your PC looks through the drives to find an operating system. For example, you can have the BIOS set up so that your PC first boots from a USB drive, then from a CD-ROM drive if you have one installed, and then after that it'll boot from this hard drive, and if the hard drive isn't there, then maybe it will try to do a network boot. So inside of BIOS we specify the boot order, and we can run multiple operating systems from multiple different devices on that PC. So after BIOS loads, it loads the operating system. And that operating system, like I just said, can come from many sources. After the operating system loads, the final step on the PC then is to possibly log in and then load your personal settings. The operating system here could be Windows 7, it could be Linux, it could be Mac, uh, or a whole host of other OSs that may be proprietary to that particular system. On the router now. The router goes through the same exact process. It first loads post. Post, power on self-test, checks the hardware. After post is done, loads the bootstrap. Bootstrap is the BIOS. We just call it bootstrap on the router. And if you think about it, bootstrap is an appropriate term for it because you got to pick yourself up by the bootstrap sometimes to get going. And that's exactly what the bootstrap is doing. It's ending that cycle of needing an operating system to use the hardware. So we pick ourselves up by the bootstraps, and then the bootstrap loads iOS. Cisco's version of iOS, the internetworking operating system, which let me add, is completely different than Apple's iOS. Completely. They are not even remotely close. They are written by different people, have different purposes, don't even overlap in any way, shape, or form, except for the name. That is it. They are alike in name alone. So, this internetworking operating system is what drives the router. It's what handles routing. It's what gives us the ability to configure information on the device. It lets us filter traffic. It is literally the operating system that allows us to do work on the router. After our operating system is loaded, we then load the configuration files. So any configuration on the router will then be loaded last. So if you look at this, post bootstrap iOS config on the router looks very similar to the PC. Post BIOS OS personal settings. They're very, very, very similar in how they boot up. Why do we go through this? Couple reasons. Like I said, one, you need it for troubleshooting. Two, you are definitely going to be asked questions on this on the CCNA. Definitely. So you should study it up and know the process. The second piece of information about this boot up process that you need to know is what piece of memory everything is stored in. So if you look at the PC again, the PC is pretty simplistic in this respect. We have power on self-test. That's built into the hardware. We do not need memory for that. The BIOS. On a PC, the BIOS is stored in something called CMOS. CMOS stands for Complementary Metal Oxide Semiconductor. Well, hopefully you know what that is, because we're moving on. Actually, no. What CMOS is a CMOS is a type of old school rewritable memory. It is essentially, I guess the best way to describe it is it's like a USB flash drive almost. It just uses a different technology actually to store data than the flash drive does. It's really old technology. It's been around for a very long time. We store our BIOS, the basic input-output system, we store that in CMOS. The operating system on a PC, that is usually stored on a hard drive. Sometimes we store it on a thumb drive. Sometimes we put it on a CD. But ultimately, it's going to be on the hard drive as well as our personal settings. We keep those on the hard drive. And on a PC, it does a pretty good job of managing that for the end user. We've gotten really good with consumer users to help them manage their disk space and where files are located and things like that. On the router side, Cisco didn't give much concern about that, so we have a little bit more complicated system, although it's not really more complicated, it's just that we got used to this graphical user interface on PCs, at least most of us did. And when we got used to that, we forgot that there is this whole command structure in the background that's actually implementing all the things that are happening when we click our mouse on the screen. So the router kind of abandons that idea of the graphical user interface, so we just have to relearn how to access the same information that we access on the PC with iOS. All right, let's take a look at the router and how it boots up and what memory is used. Post, once again, is built into the hardware. No memory required for that. The bootstrap is located in a place called EEPROM. Now, EEPROM is a type of ROM, read-only memory. But it's a type of read-only memory that's actually a contradiction of itself, because EEPROM stands for Electronically Erasable Programmable Read-Only Memory. So it's read-only memory that we can erase and rewrite to, much like CMOS. iOS, the Internetworking Operating System, is stored in flash. And that flash memory is just like the flash memory of a USB drive. As a matter of fact, on a lot of routers, it's going to be stored as the old school compact flash card that you used in old school digital cameras. So we store our iOS in flash, and then last we store our configuration file in this strange little piece of RAM called NVRAM. Now RAM is random access memory. It is the memory we use on our PC or the router while the device is running. So RAM, not NVRAM, but RAM, random access memory, is what we use on our devices to temporarily store information while the device is powered on. Once we turn the power off to the device, all of our brains of our memory, the RAM, disappears. So our RAM goes away when the power is off. When the power comes back on, we reload the RAM and we start using it again. NVRAM, non-volatile RAM, what happens there is we use that to store very small files on our system that we don't want to have erased when the router is turned off. So NVRAM works kind of like flash in this respect, in that it's storing information in this small little piece of hardware on the board of the router to keep our configuration file.